Tell me about a time you disagreed with a senior developer. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand whether you can disagree respectfully, whether you can communicate with more experienced engineers, whether you use facts instead of ego, how you handle technical conflict, whether you can listen and learn, whether you can explain trade-offs clearly, whether you support the final team decision. This question is especially important for Java developers, backend developers, Spring Boot developers, full-stack developers, junior software developers, senior software developers, team leads, Agile teams. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you disagreed professionally, presented evidence, listened to the senior developer, and helped the team choose the best solution. Question. Tell me about a time you disagreed with a senior developer. Example 1. Disagreeing about returning all records from an API situation. In one project, we were designing a customer search API using Spring Boot. A senior developer suggested returning all matching records from the API because it would make the first version simpler for the front-end team. I understood the goal, but I was concerned about performance and scalability. Task. I needed to share my concern respectfully and suggest a safer API design. Action. I first listened to the senior developer's reasoning. Their point was valid because returning all records would make the initial front-end implementation simpler. Then I explained my concern using technical risks. Returning all records could cause large response payloads, slow API response time, browser performance issues, database load, timeout risk, memory usage issues, poor scalability as data grew. Instead of just saying the approach was wrong, I proposed an alternative. I suggested using pagination with Kirk default page size, Kirk maximum page size, Kirk page number, Kirk total records, Kirk total pages, result list. I also showed that other APIs in the system already used a similar pagination pattern, so the front-end team would not need to learn something completely new. I shared a sample response JSON and explained how QA could test it. Result. The senior developer agreed that pagination was safer for production. We implemented pagination from the first version. The API performed well with larger data, and the front-end integration stayed clear because the contract was documented early. Why this answer works? This answer is strong because it shows respectful technical disagreement, performance awareness, scalability thinking, use of existing standards, practical alternative, team alignment. Example 2. Disagreeing about synchronous API versus Kafka event situation. In one microservices project, we needed to notify another service when customer profile data changed. A senior developer suggested making a direct synchronous REST API call from our service to the downstream service. I felt that an asynchronous Kafka event might be better because the downstream update was not required for the user's immediate response. Task. I needed to explain the trade-off between synchronous and asynchronous communication without dismissing the senior developer's idea. Action. I first acknowledged the benefit of the synchronous approach. It was simpler to understand and easier to trace initially. Then, I explained the risks. User request could become slower. Downstream outage could affect our API. Timeout handling would become more important. Retry logic could be complicated. Services would become more tightly coupled. Then I explained why Kafka could be a better fit. The Kafka approach provided check better decoupling, check faster user response, Check retry capability. Check event history. Check easier downstream scaling. Check less direct dependency during user request. I also discussed the trade-offs. Kafka would require QX event schema, idempotency, retry handling, dead letter queue, monitoring, consumer testing. I suggested using Kafka only if eventual consistency was acceptable for the business flow. We reviewed the requirement with the product owner and confirmed that the downstream update did not need to happen immediately before responding to the user. Result: the team chose the Kafka event approach. The user-facing API stayed fast, and the downstream service could process updates independently. The senior developer appreciated that I compared trade-offs instead of simply rejecting their idea. Why this answer works. This answer is good because it shows check microservices understanding, check respectful disagreement, trade-off analysis, Kafka knowledge, business requirement validation, collaboration. Example 3. Disagreeing about skipping regression tests situation. In one sprint, we refactored shared validation logic used by multiple APIs. A senior developer felt that testing the new feature was enough because the refactor was small. I was concerned because the shared validator was also used by older APIs. Task: I needed to raise the regression risk before the change was merged. Action: I reviewed the usages of the shared validator. I found that it was used by several APIs, including older flows that had slightly different validation expectations. I explained my concern respectfully. I said, the new feature tests are passing, but since this validator is shared, I think we should check the existing flows that depend on it before merging. Then I suggested a focused regression plan instead of a large test effort. The plan included check new API validation, check older API validation, check missing optional fields, check required fields, check invalid input, check valid input, error response format, check backward compatibility. I also suggested adding unit tests around the shared validator so future changes would be safer. Result: the senior developer agreed to add the focused regression coverage. The tests caught one older scenario that would have behaved differently after the refactor. We fixed it before release and avoided a production regression. Why this answer works. This answer is strong because it shows check shared code awareness, check regression prevention, check respectful code review, check QA collaboration, check quality compatibility thinking, check quality ownership. Example 4. Disagreeing about a quick fix versus root cause fix situation. In one production support case, users reported intermittent errors from a backend API. A senior developer suggested applying a quick workaround to reduce visible errors immediately. I agreed that reducing user impact was important, but I was concerned that the workaround would hide the real root cause. Task: I needed to explain why a focused root cause fix would be safer than only suppressing the error. Action: I first acknowledged the urgency. Then I reviewed logs, request payloads, correlation IDs, and recent changes. I found that the issue happened when an optional field was missing from the request. I explained. The workaround may reduce the error message, but the actual issue is missing edge case handling. If we only suppress the error, some requests may still be processed incorrectly. I proposed a balanced plan. 6. The null safe handling. Keep the change focused. Avoid unrelated refactoring. Add regression tests. Ask QA to validate the affected scenario. Monitor logs after deployment. This addressed the urgency while still fixing the root cause. Result: the senior developer agreed with the focused root cause fix. The issue was resolved quickly. The regression tests helped prevent the same issue from returning. Why this answer works. This answer is good because it shows, production maturity, urgency awareness, root cause analysis, respectful disagreement, safe hotfix approach, accountability. Example 5. Disagreeing about database query approach situation. In one project, we needed to build a report API that joined multiple tables. A senior developer suggested writing one large query to return all required fields in one call. I understood the performance benefit of reducing multiple database calls, but I was concerned the query would become difficult to maintain and test. I needed to discuss the trade-off and help the team choose a balanced approach. Action. I reviewed the proposed query and the reporting requirement. The large query had benefits: fewer database calls, single result set, potentially faster execution, simpler service orchestration. But it also had risks: collection, difficult readability, harder debugging, complex joins, risk of incorrect totals, harder unit testing, difficult future changes, possible performance issues if filters changed. I suggested breaking the query into a clearer structure using smaller logical parts or a database view, depending on team standards. I also proposed checking the query execution plan and adding tests for the calculation rules. We reviewed expected data volume, indexes, filter conditions, sorting, calculation rules, report accuracy, execution plan. Result. The final solution used a cleaner query structure with proper indexing and focused tests. The API performed well and was easier to maintain. The disagreement led to a better design because we considered both performance and maintainability. Why this answer works? This answer is strong because it shows database, design thinking, performance versus maintainability trade-off, respectful discussion, evidence-based decision, testing awareness, practical compromise. Example 6. Disagreeing about adding a new library situation. In one project, we needed to generate PDF reports. A senior developer suggested building a custom PDF generation utility so the team would have full control. I understood the reason, but I felt using a mature library with a simple wrapper would reduce delivery risk. Task. I needed to explain why a library-based approach might be better without dismissing the custom solution idea. Action. I compared the two options. A custom solution would provide cut, full control, cut, no external library dependency, custom formatting flexibility. But it also had risks: more development time, more testing effort, more formatting bugs, higher maintenance cost, less documentation, more edge cases to handle. Using a mature library would provide faster delivery, tested functionality, formatting support, documentation, community examples, less custom code. To reduce dependency risk, I suggested creating a small wrapper around the library. That way, our business logic would not be tightly coupled to the library. I also suggested a small proof of concept before finalizing the decision. Result. The senior developer agreed to try the proof of concept. The library-based approach worked well for our needs. We delivered the PDF feature faster and kept the code maintainable through a wrapper. Why this answer works? This answer is good because it shows, yes, build versus use library judgment, delivery awareness, maintainability thinking, respectful disagreement, proof of concept approach, practical architecture. Example 7. Disagreeing about deployment timing situation. In one release, we had a backend change ready to deploy late in the day. A senior developer felt we should deploy because the change was already tested and the release had been delayed once. I was concerned because the change touched shared validation logic and support coverage would be lower after hours. I needed to raise the deployment risk respectfully and suggest a safer option. Action. I first acknowledged that delaying the deployment was frustrating. Then, I explained the risk. The concerns were: check, shared validation logic changed, multiple APIs could be affected, lower support coverage after hours, limited QA availability, harder rollback coordination, less monitoring attention. I suggested deploying the next morning instead. I also proposed using the extra time to prepare. Smoke test checklist, affected API list, rollback plan, monitoring checks, QA validation scenarios, support communication. I made it clear that I was not blocking the release unnecessarily. I was trying to reduce production risk. Result. The senior developer and release team agreed to move deployment to the next morning. The deployment went smoothly. Because the full team was available, smoke testing and monitoring were completed quickly. Why this answer works? This answer is strong because it shows CURT, production risk awareness, deployment judgment, respectful disagreement, safer release planning, monitoring mindset, team-first thinking. Example 8. Disagreeing about caching strategies situation. In one project, we had a read-heavy API that returned reference data used by multiple screens. A senior developer suggested adding caching quickly to improve performance. I agreed that caching could help, but I was concerned that we had not yet defined cache expiry, invalidation, or stale data behavior. Task. I needed to explain why caching needed a clear strategy before implementation. Action. I first agreed with the goal of improving performance. Then I explained that caching without clear rules could create incorrect user-facing data. The important questions were: how long should data stay cached? What should trigger cache invalidation? Can users tolerate stale data? Should cache be per user or global? What happens if cache refresh fails? How do we monitor cache behavior? How do we test cache expiry? I suggested a simple caching design. Clear TTL. Use a clear TTL. Avoid caching user-specific sensitive data. Log cache hits and misses. Add fallback behavior. Document stale data expectations. Add tests for cache expiry. Result. The senior developer agreed that caching needed clear rules. We implemented a safer caching strategy. The API became faster without creating stale data confusion. Why this answer works? This answer is good because it shows caching knowledge, performance awareness, data correctness thinking, respectful technical disagreement, practical design, production reliability. Best short answer version. If you need a short interview answer, you can say, in one project, we were designing a customer search API. A senior developer suggested returning all matching records because it would make the first version simpler for the front-end team. I listened to their reasoning and understood the goal of keeping the implementation simple. But I was concerned about performance and scalability because the customer table could grow significantly. Returning all records could create large payloads, slow response times, browser performance issues, database load, and timeout risk. Instead of just disagreeing, I proposed pagination with a default page size and maximum page size. I also showed that other APIs in our system already used a similar pattern, so it would stay consistent and still be manageable for the front-end team. The senior developer agreed, and we implemented pagination from the first version. The API performed better with larger data, and the front-end integration remained clear because the contract was documented early. Common mistakes to avoid. 1. Making the senior developer look wrong. Bad answer. The senior developer did not understand the issue. Better answer. The senior developer was focused on keeping the first version simple, and I shared the scalability risks so we could make a balanced decision. 2. Disagreeing based on opinion only. Bad answer.
I felt my approach was better.
Better answer. I compared the trade-offs, checked existing system patterns, and explained the risks. 3. Ignoring their experience. Bad answer. I told them we should not do it that way. Better answer. I listened to their reasoning first, then shared my concern respectfully. 4. Only saying no. Bad answer. I disagreed with the approach. Better answer. I explained the risk and proposed a practical alternative. 5. Not supporting the final decision. Bad answer. They chose their approach, so I stopped pushing. Better answer. After the team made the final decision, I supported it professionally and helped deliver the solution. Best practices for answering this question. Use the STAR method. Choose a professional technical disagreement. Respect the senior developer's experience. Explain their point of view fairly. Use facts, examples, and trade-offs. Avoid ego or personal conflict. propose alternatives, show collaboration, support the final decision. Result: what interviewers are looking for. Interviewers want to see whether you can check, disagree respectfully. Check, communicate with senior engineers. Check, use evidence. Compare trade-offs. Handle technical conflict maturely. Learn from others. Influence without authority. Support team decisions. For senior roles, they also want to see check, technical judgment. Check, architecture thinking. Production awareness. Risk communication. Collaboration. Mentoring mindset. Decision-making maturity. Strong words to use in your answer. You can use words like respectfully raised, listened first, acknowledged their point, compared trade-offs, explained the risk, proposed an alternative, validated with evidence, aligned with the team, supported the decision, balanced simplicity and scalability, reduced risk. Example: I listened to the senior developer's reasoning first, then respectfully explained the scalability risk, proposed a practical alternative, and helped the team align on a solution that balanced simplicity and production readiness. Good senior developer disagreement topics you can use. Depending on your experience, you can talk about returning all records instead of pagination, synchronous REST call versus Kafka event, skipping regression tests, quick fix versus root cause fix, large database query versus maintainable query design, custom solution versus library, deployment timing, caching strategy, feature flag versus direct release, merging risky pull request, check, refactoring shared code, check, API error response design, check, logging sensitive data risk, check, skipping documentation, check, handling technical debt.
Final summary.
Tell me about a time you disagreed with a senior developer is an important interview question because software teams need engineers who can discuss technical differences respectfully and professionally. The best answer should include what the disagreement was about, what the senior developer's view was, what concern you had, how you explained your reasoning, what trade-offs you compared, what alternative you proposed, how the final decision was made, how you supported the outcome. Good examples include pagination decision, REST versus Kafka, regression testing, quick fix versus root cause fix, database query design, custom solution versus library, deployment timing, caching strategy. The strongest answers show respect, technical judgment, evidence-based communication, collaboration, and maturity.